sense, and we'll work on upland clay soils, and some of them don't. And we haven't done the science to figure that out, but we do know that our sort of, you can't just cut and paste what we do here in Sandhill, even on our music forests like at Flint Rock or St. Mark's or what have you. So I definitely encourage conversation about that. It's not to say that it isn't worth talking about. I just know that we don't know all the answers to that. And so take all of this with a grain of salt unless you intend to apply it on Sandhill, because it is very site-specific. And I'm going to do my best to get us right on track with lunch, so I might breeze through this a little bit quicker. I do want to spend some time talking about some of these questions about music flatwoods that may be stuck in sort of a landscape scale trap, and there's been some good research about that I'll mention. I encourage you to go hunt down a paper that deals with it rather directly, and talk a little bit about some of the land management approaches to try and avoid landscape scale traps where we had once really healthy understory in flatwoods that has largely been converted to sort of a shrub disaster that's really hard to burn, really hard to get back on track, and that's something that I know a lot of us struggle with. So I'll talk about that as well. So welcome to ABRP. I'll talk a little bit about our history here on the property, but I'm going to kind of breeze through this a little bit quicker just to keep us moving. To give you a little bit of context about the Nature Conservancy's work here in the eastern portion of the Florida Panhandle, all of the stars are individual properties that we own, and those that are indicated by a red star are ones that we use prescribed fire, oftentimes as the only or at least the predominant management tool on them, and we are currently right here, right on the edge of the Apalachicola River. For those of you that don't know, the Apalachicola Regional Stewardship Alliance goes from the Osceola River to the Choctawhatchee River. It encompasses about 1.4 million acres of conservation land, so publicly owned conservation land, very rich. And a lot of that conservation land is kind of pooled together between the Apalachicola National Forest, Tate's Hell, along the coast of St. Mark's, up the Osceola River. So we really are quite blessed in this neck of the woods for our abundance and concentration and connectedness of public lands. But there are challenges that we face on a lot of those lands. As I mentioned, here we are at ABRP. The Cody Scarp is right about here, where we have a major soil shift from clay-dominated soils, or at least a clay portion of the soils, to sandy soils right about there. And a lot of our sandhill properties in this region are kind of, on the north end of the National Forest, up here on the north end in Liberty County. And as we sort of grade down towards the coast, our forests tend to get wetter and more into our flatwoods types. So the lessons that we've learned here, are applicable kind of within a band of our alliance area, and then a lot of us struggle with what to do closer to the coast. So this is the Bluffs track of the Apalachicola Apalachicola Bluffs and Ravines. It's about 5,000 acres, bound by Highway 12 and 270, and you can see the sort of unique landforms that we have. We share this with Torrey State Park right across the street, which are these steep head ravines. We bought the initial purchase of this property back in 1982, which is currently our Garden of Eden tract, which is down here sort of on the south corner. And then the bulk of the rest of the property we bought in 1984. And the reason that we bought it was sort of threefold. First of all, these unique landforms, these steep head ravines, they're very unusual. Liberty County has an abundance of them. There's a little bit in Leon County. And then really over most of the rest of the planet, there isn't a lot of other examples of this. So Nature Conservancy and the state have both recognized how important this is as a sort of a driver of biodiversity. And so we bought up much of what we could. There has been some really interesting geophysical research on how the erosion that is typical in this sort of setting where we have 100 to 150 feet of well-drained soils, and then underneath that 150 feet we have the water table, which is sort of this slurry of sand and water, and how that dynamic creates these steep head ravines where the walls and the head of each one of these ravines are on geological time are basically having these little catastrophic failures, and sand is heading down to the Apalachicola River and carried out to form many of the islands that we love. So anyway, this very unique erosion process is what forms this. And of course, what results at the intersection of these two different ecosystems is we have blendings of plant communities that you really basically don't find anywhere else on Earth. We've got upland, sandhill, and then within just dozens of feet, basically the equivalent of a hardwood forest. So really unique combinations of plants growing there, and it allows us to ask some interesting questions about the way that the ecology works, which hopefully we'll be able to do more and more of that kind of questioning. But the other interesting thing about this piece of property is it is several of these ravines are sort of directly inundated and fed by the Apalachicola River, which receives at least a portion of its water from snowmelt up in the Appalachian Mountains, which means that this water body is relatively cold. And because these ravines are set 100 to 150 feet below the areas around it and they're canopy covered, these ravines basically act like little refrigerator museums of species that were forced down during the last glaciation. They are comfortable there. It's 10, 15, 20 degrees colder than everywhere else around it. And after the glaciers receded, lots of those plants couldn't find a home in these uplands. It became too warm. But in the ravines, they were able to persist. And so we have disjunct populations of mountain laurel, things like that, even toria, that we just don't find anywhere else in the area. So that made this property a pretty huge conservation bang for the buck, because we have species here that you don't find anywhere else, also living in context with species that they don't often live next to. So very interesting piece of property for us to buy, and a pretty huge conservation win. At the time when we bought it in the 1980s, the predominant thought was a piece of property like this, you could just throw a fence on it, throw a padlock on it, walk away. We didn't have any facilities here. This was sort of a portfolio piece for the Nature Conservancy at the time. And of course, what we learned in the decade or so following that is that the plant communities, especially in the ravines, were declining. Our tree species weren't regenerating. There just was no good forest health. And that's when we realized that you cannot just walk away from a piece of property like this that is really dependent on regular management, oftentimes in the form of disturbance like fire. And so what was here, and I'll show you some interesting pictures in a second, was a failed slash pine plantation. I've got somewhere around here, we've got a cookie from one of the slash pines was here. Very, very tight rings. This was a 45, 50-year-old slash pine that was cut off the property when we bought it. This was sort of typical of the tree growth that we had on the property. You might know now that slash pine doesn't like to be on 150 foot of sand. So it was not a very productive site when we bought it. And of course, after having been a slash pine plantation for dozens of years, there was basically nothing in the way of ground cover for us to reintroduce fire with. So in the context of some of the comments about finding out what's there, maybe letting it burn a couple times and figure out what you got, we really had almost nothing, and I'll talk a second about that. But we did know, in contrast to some other places around here, that we did have to do basically a soup to nuts, ground to top restoration project if we wanted to get fire back, which we knew at the time was really essential for managing the health of those ravine habitats. So it's interesting that the original purpose of this property was intended for the health of these ravines, but a lot of the work that we've done in the uplands has really sort of, provided information for a lot of upland management that I think has been a big magnifier for us. This is what it looks like down at the bottom of the ravines. Again, that was the original purpose of purchasing this property, but the lessons that we've learned, I think, have gone way beyond the conservation of just those habitats. This is a 1940 aerial image. Before this property was a slash pine plantation. You can see the sort of lighter gray spotted area was the uplands with mixed understory herbaceous species, and the little dark dots are pines, longleaf pines at the time. And keep an eye on this little corner. This is the Garden of Eden tract, because we're going to get to see the insult, as Joan called it. So by 1959, the property was turned into an industrial slash pine plantation. Again, here's that same corner. And just take a minute to note the difference. There still was some remnant understory in this portion. Again, this is our Garden of Eden tract, which would ultimately become the major donor source of all of our understory material for the rest of the property. Now, if this looks like a white piece of paper with Sharpie drawn lines on it, it is an aerial image of the windrows that the Industrial Timber Company put in. It was a not untypical land management strategy at the time to reduce competition for the pines that they were putting in the ground. So basically all of the understory, all the topsoil was pushed together into these windrows, and the trees were planted in between them. There were some portions up near the ravines that didn't get quite so insulted, and so those have also been able to be some donor sources for us to be able to get material from. But by and large, this portion of the property was owned by a different timber company. And they also windrowed, but you can see the precision wasn't quite there, and the intensity wasn't there. So there was still some decent material there for us to work with. And when we went to the textbooks to find out how you do this ground cover restoration stuff, this was in 1989, 90 or so, there basically was no information on how to do it. So we knew we needed to start with some very basic fundamental science about how to grow these species, which species are the most important, and I'll show you in a minute some plots that we did early on to help sort of figure that out. I guess we're going to do that now. So I'm not going to bore you with all the details, but this slide is intended to show some of the early science that we did. We didn't know, again, here, roller chopping versus fire, questions about fertilization versus not fertilization, irrigation versus not irrigation. We ran many multitudes of years of experiments to figure out what was the most important driving factors in getting sandhill back into a functional understory. And what we determined from that, this was funded by the DOT, by the way, I should mention that, is that, yes, fire, important. Wiregrass, the basic workhorse of fine fuels in this particular area. That's not true everywhere. If you go down to the national forest, it's not necessarily wiregrass everywhere. We've got lots of drop seed and other bunch grasses that can serve the same purpose. And we oftentimes hear from people, well, it's not all about wiregrass. And that's totally true. It's not all about wiregrass. But we did figure out for this property that was sort of the major workhorse for us to figure. And we knew we weren't going to be able to sort of design systems for every species. We had to, be efficient about how we were going to do this on scale. So learning about one species was a lot more effective for us than sort of spreading out our effort and learning how to do 7 species or something like that. And we also found out fertilization and irrigation did not really increase our survivorship for wiregrass. So we started with very humble beginnings, volunteers on a clear cut here using a leaf blower with untested, unclean seed. Came from the site, so we don't have any, I don't think we had any major genetic problems with that, but certainly not scalable, right? I mean, they were probably able to do, a quarter of an acre in a day or something like that. So that wasn't going to work on the big scale, but it did help us figure out what are the major pieces of equipment that we need to have in order to scale this thing up, and we've gone through, hay blowers and sort of various different pieces of equipment to figure out what was the best. And ultimately, we landed on a system that included some sort of industrial scale equipment, but almost more importantly was our understanding of sort of the seasonal cycle of how this all has to work. So right about now, between Halloween and Thanksgiving was, when we figured that most of this wiregrass was ready to be collected. Every year it's a little bit different, and every year there's a little bit of an art to figuring out when we should really put in our effort, all hands on deck, butts and seats collecting wiregrass. There are a variety of pieces of equipment that we have used, and we still use this seed stripper. We also have vacuum type seed collectors. Folks I know have gone through pull behind UTV collectors versus tractor mounted versus ATV mounted. We've messed with many of them, and they all have their place, but what we have found for efficiency's sake is front mounted tractor collector gets us the most seed. Now we do try and add seed from other parts of the preserve that we can't get big tractors into. And so as far as bolstering our genetic diversity and getting seed from places other than these big wide open areas is important, and we do continue to use ATV collectors sort of in spotty locations where we want to try and beef up our diversity a little bit. So you can figure this is right about now. That's why we have our Groundcover Symposium right about now. No coincidence there. And once our seed is collected and we have an idea of where we want, how many pounds of seed we need based on the number of acres that we know we want to restore that given year, our seed all ends up in an open bay. We don't really worry too much about protecting it from the elements other than, we don't want a bunch of water getting in there because that can get moldy. So, we do keep it high and dry. But this is about 2,000 pounds of seed, uncleaned. It is seed mix, so we're not collecting in pure wiregrass stands. We're going to get whatever is senescent, ready to go that time of year. That's for our bulk seed that we put out using equipment where we want to direct sow or direct plant that seed into the ground. I'll show you in a little bit. We also do hand collect pure wiregrass seed that we grow plugs out in our nursery. But a major point that we always try to make is that as far as scalability goes, plugs will never get the kind of acres that direct seeding will. It's just simply not economically feasible. So where we use plugs are in places that we know we can't get the grasslander, which is the machine that actually puts the seed directly into the ground. It's a seed drill. And because we're doing restoration on sandhills, some of those are prone to erosion. Some of them still have sand pines on them where the timber company wasn't able to get the pines off. And so we can't get a tractor to weave in and around all those trees. We will put plugs in very specific strategic locations so that we know we can get fire right down to the edges of those ravines. Again, one of the dynamics that we, I wouldn't say struggle with, but battle here in the sandhills is the ravine edge always wanting to move up into the sandhills and those not so fire pyrogenic species wanting to kind of move out of that ravine and start occupying more and more space. So we want to get fire as close to that edge as we can so we can maintain that, what we hope is sort of the historic boundary there. So we do grow some plugs, and I can show you some images of that too. But the vast majority of the acres that we restore is direct seeding with seed mix. So this seed we'll send off to a lab to get tested. We generally put out about 10 pounds of seed mix per acre, and that generally equates to about 1 pound of pure live seed per acre. And that has, you can put down double that, and actually on our tour today we'll see a site where we actually double planted one because we wanted to see how dense we can get with wiregrass and still have a functional ecosystem. We'll send this off for testing, and the results of that test will, to some extent, will determine how much seed we want to put out in that unit. If we have a really great year, meaning that for one reason or another, and we don't know the science on this, the viability is really outstanding in 1 year. It might have to do with the precipitation during the summer. It might have to do with the date of the burn. We get blocks that have just really outstanding viability, and we wouldn't need to put nearly so much seed down to get the same response. Alternatively, if we did put the same amount of seed down, we might get more wiregrass than we want and not enough of the kind of gappy spaces that lots of the other species like to occupy. So this seed will get tested, and it'll also get cleaned. One of the things that we learned from using the grasslander, which is the most, it's a piece of equipment we use predominantly for our seed drilling, is it's a little bit finicky about sending pine needles or stainless steel bolts, things like that, through the little seed emitters. So the seed needs to be fairly clean, and that is a labor-intensive process. We don't have a super flashy piece of equipment to do that. We oftentimes have volunteers or inmates or whatever, and it can be as simple as just pushing the seed through a chunk of expanded metal. It can be using an air compressor to force the good seed through and leave all the chaff and stalks and stuff up on top. But one way or another, they do need to get separated before we're ready to put that out. So this is happening basically, December, January, something like that. As soon as the seed is ready to be sown, these are the grasslanders. What's cool about this picture is that we've got 3 different tractors owned by 3 different agencies. Folks have really sort of adopted this model for the kind of scale restoration that we all do, that DEP does and FWC does and the US Forest Service does. So there is a growing pool of equipment that we can all share and utilize sort of strategically. So if somebody's got a project that's time sensitive, keeping in mind that we're going to be putting trees in this ground and the seed needs to go first because we don't want to drive tractors and grasslanders all over newly planted tubulin. So depending on how quickly those trees are scheduled to go in the ground, we need to get that seed out pretty quickly. So sometimes there can be a little bit of logistics and timing involved in getting that stuff out effectively. So basically, as soon as our seed is ready, and even just portions of that pile are ready to go, we will start sowing that seed right away, even in the middle of December. But oftentimes we're still sowing well into January. So as I mentioned, pure wiregrass is grown into plugs. We grow about 170,000 plugs per year. Again, just really for very specific strategic locations. It's extremely labor intensive. From the very beginning, from literally hand snipping the wiregrass, to sowing it by hand, to growing it for 4 or 5 months, to planting it. Every step of plug planting is more difficult than direct seeding. And the more we can encourage direct seeding, I think the more acres we're all going to get done. I can't say that enough. But we do it. And so I think folks are a little bit confused on how that works. So this is well, this picture would have been in about June or July. We'll direct sow or plant these cells. We usually use spring break labor, so folks, we have a crew from James Madison University in Virginia that comes down every spring break, and they dedicate their week off to growing wiregrass plugs for us and sleeping outside. I don't know how they do it, but so we'll have them doing this in March, and then over the course of the months between March and usually July or August, the wiregrass is just growing out in the nursery, getting irrigated every day, and a little bit of fertilizer. If anyone's got questions about the soil mix, we can talk about that too. But just know that we grow those plugs just for those sort of very specific locations where we want to make sure that we get fire and we can't get the tractor out. And then, of course, growing season fire for us is fundamental. And what we have found is that the best seed viability comes from blocks that we burn in May or June. And that's really where we focus all of our burning efforts here at ABRP. The blocks that are on schedule for burning, we will not really start until May, and if we need to go into July to get it done, we will, but that May-June window really is where we get the highest seed viability. So that's where we'll focus our efforts for locations that we know we want to collect seed on. And then here we are. This is an image of a windrow, former windrow that we spread out using a bulldozer. We didn't do that everywhere, and on our tour this afternoon, you'll get to see some spots on ABRP that have windrows that we didn't get rid of. It ended up being pretty costly and time-consuming to level all those windrows. But the idea behind leveling the windrows was to spread out that organic matter that had been all pooled up in that single kind of big composting row. One of the things that we found, and I just want to mention this, Joan, I noticed on your one of your charts, it showed Arista districta as wind dispersed. And what we have found is that it does not seem to disperse at all. It does, but I think one of the hypotheses out here is that maybe it was more animal dispersed than wind dispersed, because where we have planted these windrows with wiregrass, the thought was they would fill in the inter-windrow space, which is significant, hundreds of feet in between these windrows. And over the course of the last 25 years, there's been basically almost no movement of wiregrass into those places.
Yeah, I think it also moves with surface water. When it's moved around with water, which is also really slow. I mean, it doesn't invade. And I think some of the work that's been done at the Jones Center shows some establishment, some distance, but not huge distances.
Right.
And maybe that is animal.
Right.
I don't know.
Or if you just get used to it only moving like 1 foot or less.
Yeah,
in a decade.
and there was also work just done at Savannah River site that shows really virtually no invasion from reference sites or residual sites into other sites. So I think that, I guess, maybe I didn't mean to say that it was wind dispersed. It's wind pollinated.
Oh, okay, maybe that's what it was. Maybe that's what that comment was.
But anyways, go ahead. Sorry.
Okay, no, that's fine. What these flattened windrows have provided us, though, is a really great big alleyway to collect seed on. So it's been a very efficient way for us to get those big tractors out and collect massive amounts of seed in a pretty short period of time without having a lot of obstacles to move around. Some of these windrows we've planted with Longleaf, and now they've got obstacles, and some of them we haven't, and so we kind of just play with that mix a little bit, depending on how much seed we need to get. So we've essentially, I'll go to this map real quick, we've essentially done the ground cover restoration on the vast majority of the 5,000 or so acres here at ABRP. And through a great partnership with DEP, we have taken this process across the street over to Torrey State Park and have already restored, Mark, 2,500 acres?
More than that. 75%. So.
75% of the total sandhill sand pine plantation that we are converting back to sandhill over at Toria. So it's been a really successful project for this area. I think generally speaking, everything that we've done at ABRP has pretty much worked at Toria. So as far as the geography and space and stuff like that, it's all translated really pretty smoothly. And we'll get to see, so here we are, this is ABRP right down here in the corner. We'll get to see some of the earlier restoration zones that are now 5, 6, 7 years old on our tour this afternoon. We're not going to be able to get to a clear cut, which is sort of the step one of converting these sand pine plantations back to sandhill, because it's just a little bit too remote. But just be aware that a lot of this area is now already in one phase or another of that restoration process, and a lot of what you're going to see today is really great ground cover with longleaf that are like about that big. So you can just sort of picture them in the next 40 years as on trajectory. As long as we keep burning them, every 2 to 3 years, that's the key. We have been able to introduce fire to a clear cut within 40 months, and we feel like that's a really important number because as soon as that clear cut happens, the clock starts ticking. And again, this is where the difference between Sandhill and Music Flatwoods lies, is that you don't even get 40 months in Flatwoods. In Sandhills, we have the benefit of very, very dry sites and thus less competition. But if we don't get fire onto that site pretty much as quickly as we can, and that has to do with the longleaf being old enough to survive the fire and there being enough fuel there to carry, then we will get overtaking sparkleberries and oaks and other woodies that will basically change the dynamics of that fine fuel to something that we might even have to start over with. We haven't had to do that because we've been able to get fire there really pretty quickly. But that 40-month, for us, that 40-month is a really clinch time. That as soon as we can get fire in there, and then thereafter, every 2 to 3 years of growing season fire, everything has pretty much stayed on trajectory. We've had to do some mowing, where some of the bigger established oaky shrubs, want to kind of spread out, and they must have enough root resources to be able to withstand all the resprouting we can throw at them. But a little bit of mowing here and there seems to bring things back on track, and you'll get to see some of that this afternoon too. Okay, so I want to try and get through this Flatwoods question pretty quickly so that we can get to lunch. But basically, some of the sort of fundamental ecological questions we have in these higher competition, wetter sites have to do with the fact that once upon a time we had Flatwoods out there that had, a basal area somewhere in the 30 to 80 square foot per acre. And I'll just mention that these numbers come from Nature Conservancy, as well as a recent Environmental Defense Fund habitat quality tool that they put out. And these basically jive with America's Longleaf Restoration Initiative as sort of the desired future condition for canopy, mid-story and understory. 30 to 80 basal area of canopy, less than 10% shrub cover, which that's a pretty high bar. And then, anywhere from half to entire coverage of herbaceous understory. We all know lots of flatwoods that you cannot qualify as being in very good shape if that's what our desired future condition is. So over the course of the last 100 years, between bedding and fire suppression, we've had a pretty significant conversion from that predominantly herbaceous understory to a predominantly woody, shrubby understory. And that's a fuel shift, right? Baby longleaf aren't going to survive that fire. Herbaceous understory is going to continue to diminish with that woody kind of consumption of space. The woodies will kill our longleaf, whether they're as babies coming up or even if we get really high dry fires where the predominant fuel is woody, we'll get intensive canopy scorch and trees just can't survive everything. And then what we've noticed is that either in clear cuts or in gap conversion strategies, that a lot of those woody species are just quicker to respond to that new light availability than either the longleaf that we put in the ground or the herbaceous species that are there. So a lot of this, a lot of the understory was sort of trapped under a dense canopy for maybe 20, 30, 40 years. We open it up, and the first thing that takes advantage of that new lower competition is a lot of the shrubs. In our case in Flint Rock, it's tie-tie, it's gallberry, and those are species that respond really quickly to both gap openings and fire. So it's sort of a head scratcher on how to get longleaf the perfect little window that it can get up and above that shrub layer and start contributing to the fine fuels that we need to keep it alive. So here's some research that Chuck Hess and Walter Schenkel published just this past year, looking at gap openings as well as row thinnings on the Apalachicola National Forest. And I just use this as a way to sort of demonstrate that the work is out there. Folks are recognizing that this is a problem, but what we don't really have still out of this is a really great solution. So what this graph shows is ground cover percentage on the bottom, as well as the percentage of the plot that got burned. And you can see as we get higher and higher into the percentage cover of good herbaceous understory, more of the plot gets burned. Where we have less and less of that ground cover herbaceous and more woody, we're getting down into less than half of the plot actually carrying fire through it. On the flip side, in some of the openings here, we've got every third row thin, every other row thin. So every third row thin is the equivalent of 33% of the total cover has been removed, 50% of the total cover has been removed, and then a small gap and a large gap. And on this axis, we've got the percentage of the plot burned. And you can see where there's more and more of that canopy removed, we get less and less of the plot burned. And what this, in this paper, equates to is that needle loss. That as we remove that canopy, that needle contribution is significant, and not even the herbaceous understory is really able to compensate for it. In fact, in several of the plots, there was a whole 8-year gap between the treatment and the next time it burned. So you can think of 8 years of potential accumulation of fine fuels, whether it's needle cast or whatever, and it almost didn't matter. So you can see this sort of pattern. I'll go back. Pattern's just about the same, even with 8 years of accumulation of fuel. So that needle cast is super important. What this is telling us. So here in our regional stewardship alliance, we've got the Apalachicola River WEA, Tate's Hell, the Apalachicola National Forest, St. Mark's, our Flint Rock property, Tyndall. We're all struggling with this ugliness and how to get it into something that we feel like is on trajectory. We don't even really know what trajectory exactly looks like. We do know that folks have tried multiple years of insults, burning, chopping, mowing, herbicide, burning it again. One site prep prescription out of Tate's Hell would basically require 8 to 10 years of site prep before those longleaf are able to go in the ground. And of course that is just really, really expensive. So if we can afford to do it, great, it seems like it works. But I think the mission here is to find out how we do this in a shorter amount of time and cheaper. Oh, and I also reference our ARSA Longleaf Conservation Plan, which again is over there. On the back side of that executive summary is our top 10 action items that we think we need to really push as far as getting longleaf back on the landscape. And number 5 is figure out how to grow longleaf in these flatwoods. So it's right there. So what we've done out at Tate's Hell is basically plugged right out of the manual out at Tyndall Air Force Base, where Dan Childs, who's a forester, who's been there for 20 or 30 years, has been struggling with this very concept and came up with this idea of creating sort of functional alleyways where it's easy to do work, it's easy to get equipment in and out of, and attempts to balance that need for longleaf to have enough light, but also enough contribution of pine needles all the way into the alleyway from the surrounding remnant canopy. So in this case at Flint Rock, we've got slash pine that we left bordering a 4-row wide alley of removed longleaf that we then focused all of our site prep efforts into and then planted longleaf into it. So this is kind of what it looks like on the ground. This is a 4-row wide alley surrounded by 2 rows of remnant slash pine. So we call this 4-2-1-2 because we have a 4-row wide alley removed surrounded by 2 rows of remnant pine and then 1 row that we pull out in between the 2 rows, and that's mostly to keep these pines healthy, right? I mean, this is in part about managing that remnant canopy so it continues to do us some good. We need it to continue to provide needle cast, but we also want to see these trees grow healthy. The economics coming off of this property are part of what's going to fund the restoration. And although a lot of those slash pines are stunted, it's largely because it needed to be thinned anyway. So that exterior row that we pulled out is to reduce competition and get some light to that outside edge of that slash pine edge and help those pines kind of keep going.
How are the longleaf doing?
That's a great question. We'll get there. So just to give you some context, this is where Flint Rock is. St. Mark's National Wildlife Refuge right here, Apalachicola National Forest. So this is partly in Wakulla and partly in Jefferson County. We did have FNA come out and do a natural history inventory out there. And the blocks that you can see surrounded by red, I know they're a little bit hard to see, but there were these 3 blocks that we did this 4212 thinning in, and you can see that they were predominantly wet flatwoods and music flatwoods. So we knew, and there actually are some remnant longleaf out there too, so we have enough evidence that this site could or should be longleaf, and that we just need to figure out sort of the technique to get it from a really wet slash pine plantation back to something more like longleaf. Which we haven't quite figured out, but that's just to give you some context. The first thing that we did was we burned the crap out of it, super hot. We did a very dry March burn, so this wasn't growing season by any means, but we have a lot of fuel in those blocks, and even doing a dry March burn was super hot. We definitely got a lot of crown scorch, and probably more than any private landowner would allow, and probably more than any agency would smile upon. But keep in mind that what we were trying to do here was shift this understory and really knock it back enough so that we could try and get something going in the ground that was going to be sufficient for longleaf. It turned out it wasn't even enough, and we very sort of adaptively managed this project as we realized that every other insult that we did wasn't enough. We ended up adding other things, I'll talk about that in a second. But one thing that I think was really fundamental to where we are now at Flint Rock was being willing to give up some of that crown, being willing to sacrifice some of that canopy. Now, the unfortunate reality is the really sad, thin, weak slash pines that were there didn't survive the fire very well, and those were in the very spots where we probably need the pine needles the most. So there is sort of a little bit of a dilemma there where to burn the understory really hot in the places where we do need future longleaf is sometimes in some of the most difficult, some of the most susceptible areas on the property, and I think that's something that we're going to continue to struggle with. But hot fire is certainly going to be part of the ongoing process here for us. So some of the adaptive management that we did before we were willing to put trees in the ground, so we did the hot burn, we waited a couple months to see how the ilex and the tai were coming back. Sure enough, they came back. It took them a while. I mean, that fire was effective for probably 6 to 8 weeks. But then as soon as it started coming back, we knew this was now May. We knew that if we waited until the following November, December to put trees in the ground, it was going to be less than we started with, but it was going to be more than longleaf was going to tolerate. So we did our prescribed fire in March. Come May, June, we did a single drum roller chop in all of those blocks. In some of the blocks where we didn't have really much in the way of remnant ground cover, even crappy fuel, but at least it was some kind of grass, we did herbicide, really focused on woodies, so we did a lot of triclopyr and imazapyr in there. We followed that up with some mowing, where we thought that the mowing was going to be helpful, especially right before planting, so that the crews would have easy access, and it was just sort of one more kick in the pants for the gallberry before it started to come back. And then in many spots, we were actually able to even get a second site prep burn in. It wasn't the most phenomenal burn, but it did carry in a lot of spaces and help to kind of add some mosaic out there. And then we planted at this rate. We put in 1089 trees per acre, which is super duper high, right? Double what most people would plant. There's a couple reasons why we did that, and some of it is not totally relevant to the story. But what we wanted to make sure of was where longleaf was going to be successful, we would rather have the problem of going in and cutting out too much than not having enough. And when getting needle cast to be a contributor to fine fuel is the primary objective, we just didn't see a problem with putting in lots and lots of trees. Now we'll have to monitor to make sure we know when to go in and start thinning those out so they aren't ridiculously competing with each other. But we did put in a lot of trees, all hand-planted tubelings. We did use the remnant beds. Now the beds had been chopped, so there was a little bit of reduction in the height of the beds to some extent, although a lot of those beds, the slash pine stump that was still in there really kind of held it together, and the roller chopping, I think, had sort of mixed effect as far as knocking down those beds. But ultimately, I think the beds are going to help us out a little bit in getting those pine trees out of the water. And we planted them pretty high, and we really kind of stayed on top of the planting contractors to make sure that they kept it pretty high. So that, you know, we know in these wetter sites those trees are going to settle down. What we didn't want to do is plant them too low and have them just basically get covered up in dirt as the rain and things, you know, sort of settled out. So the other thing I want to mention here is that we ended up with a bunch of extra trees at the end of the project and knew that that was going to happen, but we weren't sure quite how many. And so we had an opportunity here right on a very discrete line to do a comparison where we've got 4212, like I mentioned earlier, on one portion of Flint Rock, right adjacent to an area that got what we're kind of calling a real estate cut. So a very heavy thinning that was done about 8-10 years ago. So we have sort of approximately equivalent total light access to the ground, but the way that that light is distributed is totally different, right? Here we've got these wide open alleys that the longleaf pine theoretically are getting all the light they need while still getting needle cast, and then here we've got this sort of distributed canopy where all the longleaf is basically in some kind of shady condition. And we planted them at the same rate. They're also on rows. Both of these have gotten approximately equivalent burns and roller chopping. Neither one of them got herbicide. Same planting density, same planting date. So there's a chance here for us to do some interesting, you know, comparisons here between this sort of, you know, wacky, innovative thinning treatment versus more of a conventional, but hardcore thinning in those areas. So the takeaways. These trees were planted in December and January of last year, so they now are coming up on their first year. I went out there in June and did some survivalship checks, and it's great. I think longleaf will do really well on this site, except for the one plot that was under that much water when I went out there. Those ones probably won't make it, but we kind of knew there was going to be some filtering. I mean, Flint Rock is a wet site, and we planted trees everywhere, and we figure where it's going to stay flooded, they're just not going to make it, and where it doesn't stay flooded, we'll know we can grow longleaf. Canopy scorch was high, like I said, probably higher than most people would be able to stomach, but we're trying to toe that line between how much pressure we can put on the understory and still have some kind of viable canopy, and in some places we did good, and in some places we didn't do good. Like I mentioned before, the patches that had really high canopy mortality probably were the spots that can least afford it, and we're going to have to figure out how we're going to carry fire through those, because the pine needle contribution is going to be less now than it was before. What we don't know so far are these two items. We don't know whether all of this site prep and hot burning has had any kind of functional shift from woody to herbaceous. We are not currently planning on adding any seed out there. That's something that we might do in the future. And of course, we planted our longleaf in rows, so we can go back in and mow or herbicide or add seed as needed. But at this stage, we're just going to kind of wait and see how it does. And then we don't also know the effect on the overstory on longleaf survival over the long term, but I can tell you at the 6 month, when I was out at these plots, the longleaf in the 4-2-1-2 open alleys were doing excellent. The longleaf that were in this sort of dispersed canopy were certainly there and they were certainly alive, but they were already getting overtaken by gallberry. So I was able to sort of part the seeds and find the seedlings, but I think that the long term for that does not bode well as far as them being able to get up and over that. So hopefully in a year we'll be able to have some more data on whether that's working or not. And that's it. 12:20, just in time. Any questions?
Contradictory, but why couldn't you burn just before dormant season and push back the shrub layer that way so it doesn't have the nutrients, or you've killed off, you know, that last resort right before it goes dormant, and then open it up to plant in December or January?
Well, I think part of our is probably twofold. One is our hope was that an early growing season or late spring, fall might stimulate some of the understory that wouldn't be stimulated by a fire in the dormant season. So we were hoping to see some kind of veg response that would be thumbs up. I wouldn't say, I mean, we saw a lot of carex and stuff like that come up, so not great fuels, but definitely, you know, we saw a hit on the woodies and maybe some benefit to some of the finer fuels, so I think that worked out well. And then our general notion, at least within TNC, is that any hot growing season fire is going to have a disproportionately strong benefit, a harder hit on woodies than a dormant season fire. I get where you're going,
But
where
it's
they've already
yeah.
contributed all that,
Yeah.
and then you're sort of wiping it away. But the problem with waiting that long is that they've had a whole growing season to accrue, below ground resources, so resprouting, is sometimes just a pinch if all you're doing is knocking off that 1 year's growth. Versus hitting it in March or April, we're hoping to deny it a whole growing season of storing resources and getting ready for that next sprout. Yeah.
I actually have a couple questions. You said the fighting the hardwoods coming out of the steep heads and stuff like that. What do you guys do? Do you have a fire break in there, or are you just burning from the?
We won't necessarily send head fire into it all the time, but we can. One of the beauties of burning at ABRP is that it's really hard for us to lose a fire here, knock on wood. So we can oftentimes hit those ravine edges with a pretty hot, intense wall of flame. That being said, we still need to whack those edges with herbicide and chainsaws and all that stuff. We will even stack down material right on that edge so it has even more, residence time and heat coming right off of it. And we did that last year out on 270. Is that past where our tour is going to go today?
Yeah, so if we're heading back towards 12, if you're looking at ABRP, one of the steep heads that come close to the road, you'll notice a big scorched kind of bunch of dead laurel oaks off that steep head where I did a lot of mechanical treatment with a tree cutter and took the front end loader and kind of pushed it down the hill a little bit. Mainly because there was a couple of longleaf right there I didn't want to kill, but also to get a little bit more heat right there.
And two more things. And getting away from the restoration, have you seen a good migration of species from these where it probably was barren in these old sand pine type things? You seen like pine snakes or anyone doing any type of studies?
Yes,
strip fences, things
definitely.
like that?
We get funding from FWC to do biological inventories and what, sort of the cool narrative that we have. And in fact, I'll step back. A lot of the funding, the same NIFWIF, National Fish and Wildlife funding that is helping to pay for this event, pays for a lot of our restoration. And they're really keyed in on Bachman sparrows, red cockaded woodpeckers, gopher tortoises. So, and two cool little sort of stories about that. We see Bachman sparrows moving into Toria blocks months after restoration. So there's a very quick response for that. And then secondarily, as far as gopher tortoises go, this site, many of you may know, was the release site for indigo snakes. That was because we have such a healthy and diverse gopher tortoise demographics here. So we have babies, we have adults. So I think most of the wildlife is pretty happy with what we're doing.
And then finally, I'm not sure how much herbicide you're using, but with the unique assemblage of the salamanders you guys have in the ravines, is there any long-term study on the effects of amphibians in these steephead ravines with the use of herbicide?
Not that we're doing, but we did avoid those isolated wetlands where we knew they were. Flint Rock has actually one documented population of flatwood salamanders, and we know where that is, and then there's lots of ponds that we know are potential habitat for them, and so we have avoided them. However, that being said, we do use herbicide in those ponds to restore them, but it's not broadcast. It's just right on the cut stump. So aside from the efficient big scale restorations that we can do, we do these tiny little small scale, not very efficient restorations, but super important, where we have contractors go out and literally chainsaw every tie. Now we're starting to experiment with excavators pulling out entire trees and treating that stump on a very, very local scale. So it's not, and the herbicide blend that we use is as water safe as we can put together and still be effective.
Right, just real quick on your viability of your wiregrass seed. May, June is the best time to burn, but is there any difference between viability, say, versus an annual burn where you're trying to collect off the same site annually or waiting 2 to 3 years? Is there a gain-loss situation?
I don't know the answer to that because we don't burn anything that often.
Okay.
Every 2 years is as often as we do, and we do burn portions of Garden Eden every 2 years because they're such productive collection sites, but we haven't ever burned the same site every year. And I think our sense is in Sandhill, you'd probably run out of fuel pretty quick.
I'm curious if you did it annually, that your viability would go down just because they're not.
Honestly, I don't know, but judging from tree ring analysis and things like that, annual burning is probably more than this ecosystem ever really needed to tolerate, so I would suspect there might be some hidden ghosts in the go.
You know, our situation, we have more of the upland
Yeah.
wiregrass. We could sustain an annual burn. But
Yeah.
I didn't.
I mean,
We
there's
don't want to
flatwoods,
sacrifice viability.
there's certainly flatwoods that I've heard land managers say, if we don't burn this every year, we're gonna lose it.
Right.
So I think there are situations where it might need it, but I don't know what it would do to
Okay.
viability.
Are you eventually gonna phase out doing the plugs, because it's so expensive?
Well, we've only been doing it as we've been adding new acreage. We also had a tornado come through ABRP, so that opened up some new acreage. So I think it's a good question. As we get done with Toria's work, and we stop having work to do here, yeah, there would be no reason for us to continue, unless there's, some new project that we're working on. All right. Awesome. Thank you for your attention. I apologize for keeping you from lunch. Lunch should all be set up. You're welcome to stay in here if you want, but we have picnic tables set up outside. Feel free. And should we just...